Hi guys, for today's lesson we're going to be dealing with finding tangents and normals using differentiation. So first up, what do I mean by a normal? So a normal is a straight line, so it has the equation y equals mx plus c, straight line equation, which is perpendicular to a tangent. So if we remember, we've got our f of x here. This is our non-linear function. At this point right here, I've got a tangent here. A tangent, remember, is just is a straight line that literally just touches the nonlinear at a specific part on the curve. It literally just grazes it along there. And a normal is going to be a line which is perpendicular to the tangent, and it goes through that point as well. So so tangents and normals very similar, but they are perpendicular to each other. Next up is dy dx notation. This is not dy over dx, it's just called dy dx. It's another way to indicate the derivative of a function. So dy dx and f dash of x, they're interchangeable. They both mean the same thing, they mean the derivative. The reason why we like this notation sometimes is because it does refer to the rise and run of a non-linear curve. So the dy is kind of another way of saying the change in y, or the rise. So pretty much dy and rise are similar sorts of things. And dx is another way of talking about the run of an equation, so the change in x. So it's a useful way to it's useful notation, particularly in future sorts of questions. Okay, so some rules to remember. So we're going to go through the strategy for finding tangent and normal equations. So pretty much finding the equations for these normal and these tangent lines. Okay, so first up, you want to be differentiating your f of x. Differentiating f of x allows you to find the gradients at particular points along a nonlinear curve, and then you can sub in the x coordinate to find the tangent's gradient. So it's all about, this step is all about finding the gradient that you want. If you want the tangent's gradient, you've got it straight up by just substituting the x coordinate in. If you want the normal gradient, you need to take the negative reciprocal of the tangent gradient. Once you've got the gradient, you can use the point gradient formula to find your equation. So we're typically going to give you a point, so you have y1 and x1, and then you've used your derivative to figure out your gradient here, and then you can use that to figure out your equation. So for example, let's do some examples. At the point 2, 12, for the curve f of x equals 2x cubed minus 3x plus 2, find the equation of the tangent line in gradient intercept form. So we want it in y equals mx plus c form. I can pretty much show you this sort of question on Desmos. So I've graphed here this blue line. That's our desired equation. Y equals, what was it again? It's y equals 2x cubed minus 3x plus 2. As you can see, like from this point here, this box that I'm highlighting, there's my equation. And we want to find the tangent at this point up here. So that point there is 2, 12. That's the point. I want to find out the equation of this tangent line. You can see that this red line literally just touches this curve at that point. So we got to figure out what's the equation of this red line. So if I look at this red line, I can see that my gradient is very steep. Its rise is very large compared to its run. And we can see that if we go to the y-intercept is going to be negative 30. You can see it hits there. So that's going to help us find the equation, but obviously we want to use some algebra to find the equation for that red line, that red tangent line. So what we do is we start with f of x, and we want to find the derivative. We want to differentiate it because this will help us find the gradient of that tangent line, find exactly what the rise and run is. So we've differentiated this. We get 6x squared minus 3, and we need to find the gradient at this specific point. So we're going to let our x equal 2 because our 2 is right there. We substitute that in to the derivative. Our x is changing to that 2 because we want our x to be equal to 2. 6 lots of 2 squared minus 3. that is going to be equal to 21. So that's a very high gradient. It rises 21 and runs 1. So that's the gradient we want to use for this tangent line. And we can now figure out the equation of the tangent at this point by using the point gradient formula here. So our y1 and x1 is this point right here, and our m is this gradient of 21. So this is our equation right here, but we want to get rid of the brackets. We want to get y by itself. So plussing 12 to both sides, when you expand the brackets, you get y equals 21x take away 30. And that was the y-intercept that we saw on our graph, and that is our gradient. So that's the equation of that tangent line in the correct form, in gradient intercept form. Next up, the equation of the normal in general form. We want 0 on one side, and we want our x coefficient to be positive. Okay, so what we can do, well, the gradient of the tangent at that point was 21, as you can see up here. That means that the gradient of the normal is going to be the negative reciprocal. So it's going to be negative 1 over 21. So the way to figure out the equation of this normal, first up I'll show you on Desmos what our normal looks like. So it's going to be this sort of line here, this blue line. Green line. You'll notice that it is perpendicular, it's at right angles, and there's our equation. So like pretty much our y-intercept is going to be something like 12.1, a little bit less. It's not going to be a very nice y-intercept, but we need to find the equation of this green line. So the way we can do this algebraically is by using our point gradient formula. We're going to be using the same point. Oh, sorry, a little bit of a error there. Instead of 12, that was instead of this 12 here, it should be just a normal 2. So that's a 2 there, because we've got this 2 right here. So that means that's going to be a 2 down there. Sorry, just fix that up. Okay, so we end up getting this. We use this equation there. We're going to have to expand these brackets. So the easiest thing is to do minus 1 over 21 times x. That gets us this right here. The x just jumps up the top and multiplies by that 1. And the 2 times this is going to be positive 2 over 21, because negative times negative makes a positive. And once we get to this stage, we want to get rid of these denominators. We're going to multiply everything by 21. And we get this sort of function here. And lastly, we're going to, instead of minusing 12, we should only be minusing 2. And we're going to come out as, I'll fix that one up. Yep, that looks better. And we should get a final equation of, if we try to simplify this side, we've got positive x. We'd like to put our x's at the front. We've got 21 lots of y. And minus 252 take away 2. That's going to give us minus 254. And that equals 0, because we got 0 on one side. We literally plussed everything over to the other side. And there is the equation of our normal form. If I put that graph in into Desmos, I should get exactly that normal, that line that is perpendicular to the tangent and goes through this point to 12. Hope this helps you with the questions. Good luck.